In this example, I'm going to calculate heat using the heat equation. I'm given several things. I know that I have a 100 gram sample of copper. So I know that it's copper and I know the mass is 100 grams. I'm also told that it's heated from an initial temperature of 10 degrees to a final temperature of 100 degrees. So the first question I encounter says, determine the number of calories needed to raise the temperature of copper from 10 degrees to 100 degrees. And it also then in this part of the problem tells me the specific heat. So the specific heat of copper is 0.0921 calories per gram degrees C. Now, just as a reminder, heat in general, we will encounter two units. It could be calories, which is a lowercase cal, or we can encounter joules. I have other problems where I work it in joules. How you solve the problems is the same equation, same way to rearrange things. But you have to be sure if you're working in calories that your specific heat is in calories, or if you're working with joules, your specific heat is in joules. So you can't get heat in joules and use calories. So you just have to be sure you're using the same unit in a specific problem. So this problem tells us to work in calories. So to calculate the heat, which it says determine the number of calories, which is the heat, we use our heat equation, which is the heat equals mass times specific heat times the change in temperature. Remember, Q is heat, which is what calories is. Then we'll have mass times the constant, which is specific heat, that's represented by the C, times the change in temperature. Now, in this particular problem, we are given the mass, we're given the specific heat, and we're given the temperature. We're asked to solve for the calories, or what we also know is the heat. So what we're going to do is plug in those three values that they gave us, and we'll be able to multiply them and calculate our answer. So before I start, I want to get the delta T. So that's where we take the final temperature and subtract the initial temperature. So this one is pretty easy to do, 90 degrees C. So let's plug in the equation below. So the mass they told me is 100 grams. The specific heat they gave me is 0.0921. And then the change in temperature I just calculated was 90. Now, if you're like me and like to follow through with your units, which I do, we'll notice that the grams here cancels with the grams here. The degrees Celsius cancel with the degrees Celsius. And what is left is calories, which is the unit that they're asking us to calculate. So to solve this problem, my calculator, it's 100 times 0.0921 times 90. And I get 828.9 calories. Now, looking back, if I want to consider significant figures, this number has 4 significant figures. I don't normally look at constants, but I do think this one is rounded. It only has 3 significant figures. But even better, this one only has 3 significant figures. So I do think I'm going to round this to 3, and it's 828. I'm going to drop off this 9, which makes the last digit round up. So I'm going to report 829 calories as my answer. All right. Now, in this problem, which is part of the homework, it has a second component. And it says the same amount of heat. So they're just saying the 829 calories is added to 100 grams of aluminum at 10 degrees Celsius. So I'm just going to make a little to write it down. So they say, okay, now you add 829 calories to 100 gram, I think it had a 0.0, 100 grams of aluminum, and that aluminum is at 10 degrees Celsius. Then it also tells me the specific heat of the aluminum is 0.215 calories per gram degrees C. And it says, which metal gets hotter, copper or the aluminum? Now, I would only have to imagine that they would be applying this same amount of heat. Oh, I guess they said that. It's the same amount of heat. Okay, so this is not a mathematical equation. What you have to consider is only their specific heats. So in this example, it's 2.215, and for copper, it's 0.0921. So if you look, they're telling us, I'm getting a highlighter so I can see. They tell us it both has the same heat. They both have the same mass. They both start at the same temperature. So the thing that's different is their specific heat. And here's how specific heats work. The lower the specific heat, the higher the temperature is going to go with the energy. So a lower specific heat, given that everything else is the same, will rise to a higher temperature. Sorry, I'm running out of room here. So just to highlight a few of the, the important parts here. Lower specific heat. Everything else being the same, and they told us everything else was the same. Same heat, same same mass, same initial temperature. If everything else is the same, the lower specific heat will rise to the higher temperature. So looking at the homework problem that I'm looking at, it's a drop down and it says blank gets hotter. So in my example, the copper is going to get hotter because it has a lower specific heat. So the copper gets hotter since the specific heat of copper is lower than aluminum. It will heat more easily. Okay, so lower specific heat. So I'm going to write on the next page because it's hard for you not to see the problem, but to see what I'm asking. So this is a homework problem, and it has, I'm not using the right marker, sorry. It has a drop down here, and it says blank gets hotter. And then it has another sentence, since the specific heat of copper is, and then there's another blank, a drop down, than aluminum, the copper heats more. I was answering blank. So just to recall the specific heats. So we have them here. Of copper is 0.0921. And then the specific heat of aluminum, that they gave us these numbers in the problem. You don't have to memorize these. And so what it's telling me, what the specific heat tells me is the lower the number, the less energy it takes to heat that substance up. So copper, because it has a lower specific heat, will take less energy than aluminum to heat up. So in the description of this problem, they basically say, okay, we're giving you the same amounts of the metal. They're starting at the same temperature. Which one's going to get hotter? We're going to apply the same amount of energy. So in this case, in my two examples, copper is going to get hotter. Why? Because copper has a specific heat that is much less than the aluminum. And so copper heats more easily. So lower specific heats require less energy to change the temperature. So since copper has a lower specific heat than aluminum, it will get hotter because it heats more easily. All right, if you have any other questions about this, please feel free to ask me in class, and keep working at it.